okay? It should not expand, it's a waste of time. So again, this is just x minus 3. This could be minus 3 plus x. This could be minus 2x divided plus 3 over 2. That's also correct. Here, you do not have to expand, because I saw quite some of you, quite a number of submissions with expanded formats. You don't have to expand. This looks okay from all I've seen so far, and this also looks okay from all I've seen so far. Now, to the comment. Now, if you look at these pictures, like I asked earlier, in the last two, what can you say about the relationship between this? Let's go to that question. The questions, well, we could delete these examples next time. Observe y equals f of x, f inverse, and y equals x on the same axis. What do you notice? Think about the geometric relationship, and I've seen quite interesting comments. Very good. So basically, it is just a reflection. So this is like a mirror image. Okay, it's like a mirror line. So while these are just reflection, that's all I ask you to do. That's all I want. So you can see this is like a mirror line. This is a reflection. That's all. Even for this is a mirror line. So this part is a reflection of this part. This part is a reflection of this part, and so on and so forth. Okay. And similarly here, this part is a reflection of this part. This part here is a reflection of this part here, and the same thing happens here. So that's all I ask you to do. So y inverse is a reflection of y equals f of x over the line y equals x. Yes. So that's the relationship between them. And I think everybody got this as well. So if you notice, if the vertical asymptote of f is x equals a, then y equals a will be the horizontal asymptote of f inverse. Okay. So the vertical asymptote of f is the value of the horizontal asymptote of f inverse, and so on. So I think that's what everybody did. This is perhaps due to the fact that the domain of f is the range of f inverse. Yeah, you're right. You're right. So the image of any arguments in the domain, okay, the image of any argument is the domain of in the reverse form. So that's my understanding of your last comment here, Lillian, and that is right. Okay, does everybody get this? So that's for activity 1. For activity 2, I haven't graded. No, I think that's for activity 2, right? This is for 1. For this, okay, I've seen quite a number of work as well. So let's see. Activity 1, not you. I hope the construction is not so. Let's look at Clarissa's work. I hope the construction is not so noisy. Okay, so let's look at this. Let's use this as an example. All right, so this is what we have for all this. Good. As k increases, the curve becomes rounder and less sleek. The curve also moves further away from origin. Yes, this is the one I'm actually interested in. Okay, it moves further away from the origin. And this lies in the first and third quadrant. As you can see, this is first and this is third quadrant, correct. Similarly here, okay, the curve also moves further away from the origin. Can everybody see what I'm seeing? Yeah, okay. And the line the second arm, so good. Clarissa, what did you choose here? Can you talk, please? Clarissa, I can't see you choosing anything.
I chose yes, but I can't click it.
But I replied your message, I asked you to type it.
I thought you said like type it on the 4th question.
Is that what you did here?
Yeah.
Oh, okay. I mean, type it here. You could type it here, because they're different questions, but I understand. Okay, so the rotational symmetry is about the origin. Yes, there's a rotational symmetry. What do we mean by rotational symmetry? If you move the shape, if you rotate the shape, it will be exactly the same thing. Okay, if you move this shape, it will be exactly the same thing. Does everybody understand what rotational symmetry means? Okay, so it will be exactly the same thing. So this time around, it's about the origin. But what is interesting is that the rotational symmetry is not always about the origin. It is actually the origin in this case because that is where the x and y asymptote intersects. It is usually towards the intersection of the x and y asymptote. Does that make sense? So those are the things I want you to figure out before we come in today. All right, so for today, we'll be looking at okay, there's an activity about sketching, all right. Unfortunately, do you guys have access to a printer, please? I need response, please. So Leo and Brandy don't have access to printer. What do we do in that case? Callista, no printer. So what do we do now? The next activity is not something you can do on the computer, and I don't want you to start drawing. This is the next activity. Of course, we can't do it in class. So based on what you have done, I will just put the date of the day I'll be giving you. So I've given you the graph of f with no equation. So you are supposed to sketch the graph of f inverse. I believe you understand what that means. Can somebody explain how you will go about this? You have been given graph of f. How do you go about the graph of f inverse? Mike, please. No typing. This is actually an IB question. This is an IB question. I just chose one. So you have all these graphs of f. If with this graph you are to sketch the graph of the inverse, how would you go about it? I need response and fast.
Like draw the y equals x and then reflect it.
Exactly. So draw the line of y equals x and do the reflection. Does everybody get that? Okay. So you draw the line of y equals x and try to see the reflection. So it's a sketch. So in particular, if you want to do this, let me see. That is this marker thing in Microsoft Word. I've seen it before. Come on, where are you? Oh, yeah. Okay, it should be in draw, right? Okay, yes. So, in particular, okay, good. So if you draw this line, y equals x, so the reflection of this will be at -2 here. So I will look at the intercept. The reflection of y equals 5 will be as x equals 5. So once you can get these two intercepts, then I think you'll be okay to draw your line. Okay? Okay, then you'll be okay to draw your line. So if I start from here, it may not be a straight line. It's going to go like that. So even though this one comes like this. So there's a point where they will meet, right? But you don't have to show all that. So this and, okay, this. Just get these two. The intercept especially will help you in this case of straight lines. Similarly here, if you have your that, then you should see it intersects. The intercept here is what? 1. So the intercept here will be 1 as well. Okay. And so this is moving, is closer to the line. So this will be closer to the line, right? Then it's going to touch here. Then it's the asymptote is y equals 0. So the reflection will be as x equals 0. So basically, it's going to go like this. Something like that. Does that make sense? Can you talk to me, please? All right. So I'll be sending you this to do. So it's not something that will require you to return, but we want you to show me. Okay, it's in your own interest to please practice. If you are not sure what the sketch will look like, feel free to ask in the classroom, and I'm sure someone would be happy to tell you what it is. Okay, so another one is about sketching graph of rational functions based on what we have done so far. Okay, no, I think, no, okay, this is not an extension of what we did. Okay, so we've done this. This is what I'm going to send to you. Sketching graph of rational function of composites. Okay, so I think we should look at this for today. So after that, I put 5 questions here. Okay, so I'll select randomly which one we need to do later. Okay, so everybody, sketching graph of rational functions. Let's write that on the board. So it's 10th of March, it's Tuesday. So one of the things that is very important for us to learn today is finding the equation of the asymptote without using the previous method. Can someone remind me the previous method of finding the equation of asymptote for the x asymptote and for the y asymptote? How did you do it previously before today's lesson? Can I get a reminder, please? If I give you a rational function, no typing, please. Talk to the mic. No typing. Talk to the mic. Thank you. Visualizing the graph.
Trying to graph it on Desmos.
No. You're in an exam. You don't have a calculator. How did you get the equation of the x and y asymptote?
Try to draw it.
Is this guy listening to me? How do you even draw the graph without you knowing where the asymptotes are? Are you listening?
Find the domain of the function and then the domain of the inverse.
So basically, you find the domain of the function and you find the domain of the inverse. So basically, you are to find the inverse function to know what where it is undefined. Is that not? Hello?
Yeah.
Am I talking to just one person or am I talking to 11 people? Guys, I do not like this. It's meant to be an interactive class. Brandy, Karen, Clarissa, I'm going to call name, Callista, Ethan just replied. Krista, Leo, Nakita, and Vena. I do not want silence. I need everybody to say something. Thank you. So basically, if you have a rational function, maybe ax plus b divided by, this is your f, divided by maybe mx plus n, you can get the equation of the horizontal asymptote out. Can I have another person respond apart from Mr. Chang, and Miss Lillian?
We can put mx plus n equal to 0 and get the example.
Who just spoke now? That's Krista, right? Krista C. So, okay, good. So to get the first one, we do mx plus n equals 0. And of course, we get n equals that. And this is your vertical asymptote. What about horizontal asymptote? Can I hear from someone else?
You look at the coefficient of x.
What do you mean?
Like, in this case, a divided by m.
That is the horizontal asymptote?
Yeah.
Can you remind me from our previous class where exactly I said that? I'm sure you have your notes right in front of you. I'm waiting, Miss Crystal. Can someone else tell me what we did in previous class? Because that's the question I'm asking. I'm not asking you to do any foreign whatever. Yes, Brandy?
Is it you find the inverse function of fx and then you make that denominator equals to 0?
Exactly. That's what we did. Krista, have you found where we mentioned that in our previous class? I'm interested in that.
No.
So where does that come from? You read it in a book and now you're going to just mess what I'm trying to do here. I'm not saying it is wrong, but I'm asking you what we did before. So I can't remember telling you to look at the coefficient of anything. So in the previous class, you equate the original function, the denominator to be 0, and that is your vertical asymptote. Then you can find the inverse function to get where it is not defined, similarly to get the horizontal asymptote, and that's what we did before. So for today, we'll be looking at this asymptote differently. The vertical asymptote is going to be the way it is. The horizontal asymptote will take a new dimension. I'll show you another dimension. Then we can conclude what Krista said. I don't know if you understand what she said, but at the end of the day, we're going to end up getting something that she mentioned. I don't know if you understand what she has said herself. So our main objective is to be able to sketch and be able to get the asymptote in a different way, okay, using limits, right? Using limits to get the asymptote and sketching. So I write my objective as follows. Okay. That's what we want to achieve today. Just a sec, please. Oh. All right. Okay, Mr. Leo, I wonder why it's coming back, joining again. All right, that's okay. So the first thing I want us to do is to understand the idea of limits. You have a calculator, I believe. Shall we look at y equals 3? No. Okay, not even this y equals. Everybody check your calculator, or even without calculator. If you have 2 divided by x minus 1, what happens to y when x becomes large? What happens to y when x becomes large? So you can do your experiment on the calculator. If x increases from hundreds to thousands to millions, what do you notice about the value of y as x increases?
It will decrease.
What do you mean?
Like the number will be smaller, but never get to 0.
So don't just say decrease. When you say decrease, is it decreasing from 1 million to 500? Is it decreasing from 10 to 9? The word decrease doesn't really explain what I want to hear. So again, can you put it properly? When x becomes very large, what happens to y?
Y will decrease, but it will never reach to 0.
It will be closer to 0. That's better. Y will be getting closer to 0. Does everybody agree with Leo on that? You see, you guys that are typing and giving me unnecessary stress, because I have to now go and open that window. I think I'm going to ban people from typing in this class. You guys that are typing, let me see how I can change that setting so that nobody is able to type. It's a lot of stress to having to open all these things again and again. So please stop typing, talk to the mic. So this is the idea we need today, okay? So let's see. Let's write it as an observation. Given y equals a divided by mx plus n, okay, we notice that as x becomes large, that is how we write it. As x tends to infinity, that's how you read that. Or you can say as x becomes large. Okay, y tends to 0. Y tends to, or you can say y approaches. This one also you can say x approaches. Y approaches 0. So like Leo said, it gets close to 0, but it does not get to 0. So this is the idea of limit that I'm talking about. As x becomes large, as x tends to infinity, as x approaches infinity, the limiting value of y is 0. That is, y becomes 0. When I say y, I mean this function, okay? It may be f of x, it may be y, all right? So I don't want that to be mixed up when we are doing something, when we are applying this technique in our questions. So why is this important? Okay, why is this important? If you look at your graph, this is actually what happened to the asymptote. So let's, I don't know if I need to plot anything, but just do a sketch. If you have something here, and you know, asymptote looks like this, right? Now this says as x tends to infinity. So if my equation of asymptote is this, let's do that again. So this is my x and y plane. If I have my x asymptote as this, my y asymptote as this, y is equal to some number, whatever, what does that mean? And my curve looks like this. Okay, what it means is that as x tends to infinity, that is, as x increases, you see, from here, you have x is 1, x is 2, x is 3, x is 4, x is 5, x is 1 million, x is 10 million, blah, blah, blah. So as x becomes large, y, this is y value, okay? Y move close to 0, y move close to this value. So let's say this value is b. Y approaches b. So here we can say as x tends to infinity, y tends to b, but y never touches b. So this y is equal to b is your y asymptote. It's your vertical asymptote, sorry. That's horizontal asymptote, I'm sorry. Does that make sense, everyone? As x becomes large, y tends to b, then this b value is what you're looking for. Okay, that's where it does not touch. Not 0 this time, okay? So the idea that we want to do, does everybody understand before I move on, please? Hello?
Yes.
All right, thank you. So the idea that we want to do today is when given a rational function, we want to express it in that form that we'll be able to use this idea. So for today, given f of x equals ax plus b divided by mx plus n, okay? Our first goal is to rewrite f of x as some a, or let's say some k, plus maybe some number c divided by mx plus n, and apply limits to the c over mx plus n parts. That's the goal. You say something. The video is on. Oh yeah. So to the c over mx plus n parts. Does that make sense? I hope I put that right. So that is the goal. This is how we're going to be finding our horizontal asymptote limits to, sorry. Okay. So once we write it that way, that is, let's see. Such that if we have f of x, which originally is ax plus b divided by mx plus n, and we are able to write it as some constants plus c divided by mx plus n. If we have this, then we can say as x tends to infinity, it only affects these parts. C divided by mx plus n tends to 0, which implies that your f of x tends to k plus 0, okay? And that is k. So y equals k is the horizontal Does that make sense, everyone? Talk to me, please.
Yes.
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 So this is the idea we want to do. Now, Crystal said something earlier. Let's see where she got that. Because from the equation itself, you can actually pick that horizontal asymptote. And that is not to say that when I give you work, you just pick it directly. I need you to go through this process that I'm about to do. So let's see what happens. Given, let's use the same equation that we have here, ax plus b mx plus n. I hope that is not the homework that I'm going to give you later. Okay, it's not. Okay, maybe I just change it. Given px, given f of x, or y, it doesn't matter. Maybe I call it y, or f of x, it doesn't matter. So let's say given f of x equals px plus q divided by mx plus n. To write it in this form, okay, to write it in this form, the idea is to say what's going on? To write it in this form, it implies that f of x is equal to, I need this up there. So you're going to say p bracket. So I need this in the bracket, okay? Because the idea is this: if I have x plus 1 divided by x minus 1, my goal is to have x minus 1 here because the coefficient is 1, so I'm going to have x minus 1 divided by x minus 1. But I still want the result to remain this, right? I want the result to remain this. So if I'm going to do that, what do I do to the numerator to have that? So what do I say now? That will be some minus, and this has to be a number. Okay, so I have my x, I have my minus 1, then this will have to be plus 2. Do you agree? Class, do you agree?
Yes. Yes.
So with this, it will be x minus 1 divided by x minus 1, 2 divided by x minus 1. So this is your k that I meant earlier. Okay, so this is what we are trying to do, to write it in this form. Because now we can apply limit to this part and get 0, then you know that 1 is the result. Similarly, if you have x minus 1 again, x plus 1 again, but this happens to be 2x plus 1. Okay, let's see what that is. Or maybe this is 3x. Let's see what that is. I need 2 into that, right? And this is a 3. So if I have 3 and I have 2x plus 1, that's going to be 6x, right? Let's see. No, don't need that. So I have 3x. I need 2x to be at the bottom so that I can divide and get a number. So if I need to have my 2x plus 1 in the bracket, and at the end of the expansion, there'll be a constant here. At the end of the expansion, I need to have this 3x back. So that would be 3 over 2. Is it? Yes, that would be 3 over 2. Talk to me, guys. So you need to have this in brackets. Then you need to think of what constants will be here, so that when we expand, I will be having 3x coefficients again. So if my 2kx must end up giving me 3x, then what is my k? My k will be 3x over 2x, which is 3 over 2. So I must have my 3 over 2 here, so that when this bracket is expanded, I'm going to have 3x back. Don't worry about the number, okay? So when that bracket is expanded, you're going to be having 3x, then plus 3 over 2, right? But we need only plus 1. What do I do to this plus 3 over 2 to become plus 1? Talk to me.
You subtract by 1 over 2.
Good. So you minus 1 over 2. So you agree that this is exactly this numerator. So with this, then you can say 3 over 2, 2x plus 1, divided by 2x plus 1, then 1 over 2 divided by 2x plus 1. Of course, you know this becomes 0 because when x becomes large, it cancels. Now this is just 3 over 2. So what Krista is saying is just look at these coefficients because that's what you end up getting. And that's what we are trying to achieve here. Any questions, please?
No.
I'm waiting for a response from the rest. Any questions?
No.
Please don't make me announce your names before you respond. Thank you. And don't say, oh, somebody responded, that's also my response, so I need to be quiet. No, you need to reply for yourself. All right, so we're going to do the same here. We need a constant outside the brackets, and we need mx plus n inside the brackets, and we're going to add a number to it, and everything will be divided by mx plus n. Now, whatever we have here, when multiplied, must give this back. So I need to get my px. Then I'm going to say k multiplied by that. Do you understand? Yes, yes. Talk to me, please. Do you understand what I mean by this? I'm trying to get what do I multiply with. Hello? Yes. Okay.
Yes.
So if my k, in this case, will be px divided by mx, which means my k is p over m. So it means outside this bracket is going to be p over m. So when I multiply that bracket, I get p over m times mx, then p over m times n. And that will be the p, that's p, yeah, that's px plus pn over m. So px is this px is okay, exactly the way we want it. Now we need q. So something must be done to this to give me my q. So which means this must be q minus pn over m. You understand? So it means what I need to add to this is q minus pn over m. Am I making sense? This is exactly what Brandy said earlier. Okay, so you have to go through this to be able to, I'm going to give you something in form of a letter, and this is how you have to figure it out. That's the reason I'm asking all this, and that's the reason I need you to follow exactly what I'm doing to be sure that you understand what I'm doing. Does everybody understand? I can see Leo says no. I don't know what this no is. Is it from previous charts? Or is it from what I'm doing currently? This is why I asked you to speak to the mic, because I just opened this because I saw a notification.
Wait, Mr. Daniel.
Yes, Brandy.
Can you explain like this question again?
I will. Leo, first, what is this no representing? This no in the chat box.
This is the for previous one. Like you asked, anyone have question?
Can you speak to the mic next time? Because I'm just looking at it now. I don't know how long ago you already typed this no. And I need to stop looking at typing. Everybody, please fix your mic. If your mic isn't working, log in with your phone, apart from your computer, then you mute your voice on the computer and talk through the phone. Then you mute my voice on your phone so that the voice is only from one. I don't know if you get my point. So you can log in with two devices so that you can talk from one and watch whatever I'm saying from the other. That's what some other classes have done. So I'll go back again to this question according to Mr. B. We want to split this into some constants plus a fraction. The constant can only be achieved if you have k with mx plus n dividing another mx plus n. And whatever happens to this, we don't care because it's going to be 0 anyways. So that is why at the beginning, you will try to achieve this coefficient, this denominator here in the bracket. But again, when you put this in the bracket, maybe I start over. The denominator is this, so the denominator will be in the bracket by default. Something must be here. I call it k. It's a number, that's why I call it k. K will be here. Something has to be added to k, we don't care now. When you multiply, when you open this bracket, you get kmx plus kn, right? K is a number, we don't know. But we are particularly interested in the x term. This x term, because something will be here again, which we don't know yet. At the end of the day, everything will be px plus q because we cannot change our numerator. This something will be here. We don't know what it is yet. So, but for what we know, this kmx has to be the same as this, because that is the x term. Brandon, do you understand what I mean by that?
Yeah, so far so good.
So far so good, good. All right. So if kmx must be the same as this, because we can't change anything, what exactly is k? So that's why you could, somewhere in your book, just say, if kmx must be the same as px, then what is my k? So you are solving a simple equation, which means your k must have been p over m. So what number is missing here? The number that is missing here is simply p over m. And it's easy to see, it's actually this. That's the number you put outside, but I just wanted to show you why. Now, now that we have figured out k, let's now open the bracket. If you open the bracket, you're going to get p over m times mx, then p over m times n. So this is our, remember, we're going to end up doing something so that it will be px plus q, right? So this automatically is our px, which is this. Then this is what? This is a pn over m. Something has to be done to it. Okay, so this is the same as this. We don't have issue. We only have issue with this one becoming q. If everything here must become q, then this missing box must be what? Q minus pn over m. Does that make sense, Brandon?
Yes, yes.
So that is what we have just written here. That's what we wrote here earlier. So this will be plus q minus pn divided by m. And everything is mx divided by that. Does this make sense? Everybody?
Yes.
Yes.
All right, good. So if we now split this fraction using their common denominator, this implies that our fx is p over m divided by mx plus n, everything divided by mx plus n. Then you have q minus pn over m divided by mx plus n. So which means our fx equals p over m, because these two will cancel. Then this remains q minus pn over m, everything divided by mx plus n. Then you apply limits. As x tends to infinity, fx tends to p over m plus 0, because this part will be 0, which is equal to p over m. So what that means, the fx is the graph, okay? Fx is the equation of the graph. That's your y. So what we are saying is, when x tends to infinity, whether positive infinity or negative infinity, it doesn't matter. This thing tends to 0. Just a sec. So if you have one axis this way, and another axis like that, okay, I'm just using a number as a sample now. So this p over m, we don't know whether it is positive or negative. So maybe our p over m is somewhere here. So as x tends to infinity, this line, the curve does not touch this line. That's what we are saying. So as it tends to infinity, which means as time goes on, this is what happens. Doesn't touch it. Okay, the function, this y is the function. Okay, f of x is here. F of x only approach p over n, but it never touches p over n. P over n, m, sorry. Okay, so this is our equation. So y is equal to this is the equation of the horizontal asymptote that we are looking for, which implies that the horizontal asymptote is y equals p over m, which is just the coefficient of x in both cases. And that's what Krista was talking about earlier. Any question, class?
No.
No. Okay, so this is y equals p over m. That's the equation. That's the equation of that line. Y equals p over m. So this is the technique that we are going to be. So we don't have to find F inverse. That's the point. Okay. When you have numbers, it is easy to see. All right. So we don't have to find F inverse in this case. Sorry. Also, so when to sketch now, all right, this is just finding the horizontal. To find the vertical is easy. Okay. So now these are the steps we will take today. Okay, I will talk about something called a sign diagram, all right, because these are the steps we will take. Behavior of the asymptote, blah, blah, blah. And sign diagram, okay, of function. Okay, but before this, can I ask you to attempt this? I want you to find the equation of the horizontal asymptote for the following functions using the technique that we have just done. Even though I did not give a concrete example, I believe you can manipulate because I erased some things. I needed to use this technique and find the equation of the horizontal asymptote for the following functions. So let's begin. So practice 1 or activity 1. You need to show the details, how we break it down. You need to do this. Okay, you need to have that. You need to have this. You need to say as this happens and conclude. That's what I want to see. Okay. Send whatever you get on WeChat. Privately, please. 4 questions. Let's discuss these 4 questions within, if possible, 10, 15 minutes. Don't waste too much time, please. So I'll pause the video recording for now. When it is time to explain, I'll start recording again, so we do not record unnecessary parts in the video to be uploaded. Everybody get the message? Yeah?
Yeah. Yes.
Thank you. Quickly. Nikita, can you hear me?
Yeah, I can hear you.
So because you have 1, there's no reason to put 1 in the bracket.
Oh, okay.
All right? There's no need.
Okay.
So you're right. Well done.
Okay.
Ms. V, same comment goes to you. Because you have 1x, 1x, there's no need to have 1 bracket. Just say x plus 1 plus 1. Is that okay, miss?
Okay.
Hello?
Yeah, can you hear
Okay.
me?
All right. Mr. Cheng, that bracket is redundant brackets. I'm telling everybody the same thing. There's no need for that bracket. Unless there is something outside the bracket that is of interest and nothing, apparently.
Okay.
But your answer is right. So I've checked Lillian and I've... Krista, can you explain to me what is 1 over 1? Krista K.
1.
Why do you have to put 1 over 1? What is this unnecessary stress? You don't even need the brackets. It's just x plus 1 plus 1. That's all you need in this case. If there are questions that requires that, then of course you can put all these bracket and fraction. But this time around, you don't need it. So unless it is necessary, please don't. Callista received your work. Same goes to you. The bracket is redundant. We don't need it.
Okay.
And what is 2 over 1? You started your question 2. What is 2 over 1? Just write 2 brackets. If your denominator is 1, there's no point. I don't know why you guys write like that. Brandy, I don't want to see k brackets x plus 1 plus box. That is your own way of figuring it out. I don't want to see the k. Can you hear me, sir?
Okay.
What we need to see is what you can see on the screen now. Something like this. Can you see any k and box in my solution here?
No.
No. That was just an easier way of trying to figure out what it will be. So you don't have to write it. I don't want to see that. Thank you. So please take note of the corrections I've made, those of you and others. I'm expecting to see what you have done so we can correct anything that is not accurate. I'm expecting more feedback from question 1. I believe everybody should have done question 1 by now. Don't wait until you finish everything and send me a bunch of pictures. It will be too difficult to go through. Just send one after the other. I don't know why some of you wait until you finish 50 problems, then you send it at once. There's no time for that. Again, Crystal C, this bracket is a redundant bracket. When I say redundant, it means it's of no use. Like without it, we can survive. So there's no point having such brackets. I expect you to do here is to just say x plus 1 divided by x plus 1. This is x plus 1, so it's easy to write it here. And in this case, 2 bracket. You need this. This is 2, so it's easy. Then you figure out what needs to be here, divided by x minus 1, because 2 over 1 is 2. So please do not write 2 over 1 bracket. It doesn't make sense. In this case, someone is writing 1 over 1 bracket, x plus 1. What is this? It doesn't make sense. Others are writing x plus 1, then plus 1. This bracket is useless. It's redundant. We don't need it. Okay, thank you. Follow the example. If you need me to, should I keep this on the screen or keep the question on the screen? All right, checking your work. Leo, I'm checking your work now. Leo, I don't understand K bracket X plus 1 plus box. Leo, I just said that to Brandon right now, and you are sending me K brackets. I just said it to somebody. This is what gets me angry. What is this? I just mentioned it to someone else, and you just send me a message now. This is not an old message. This is the last message. I opened the last message 60 seconds ago. And I mentioned it to Brandy a couple of minutes ago. I don't understand this stuff. Then I checked number 2. It makes sense. Callista, what is this minus 2x plus 1? I don't understand this, young lady. You have 2x minus 1. Then I have plus 3 minus 2x minus 1, according to you, divided by 1. What is this?
Oh, it's 2 times minus 1, I think.
2 times minus 1. What is that?
PM.
Are you substituting what's P, what is M? Is that what you're doing? You're trying to use this formula? Is that a formula to you? So does it mean you have to rely on this PM whatever and try to memorize stuff? That shows you don't understand what I did. You're just trying to use a formula and substitute without understanding the basis of what I did. Because I can't remember having X term here to start with. And also there's a reason, can you remind me how I got this?
Which part?
This part. Can you remind me how I got that? Do you remember or not?
Wait, it's to subtract like the left part, like with the bracket of P over M times M.
Okay, I'll show you in this problem because I don't understand why you did what you did, which is similar to what Leo is trying to do as well. And I don't understand that, even though I mentioned it, and he still went ahead to do it. I don't get that part. We need x minus 1. You need to have x minus 1 inside this bracket. We need to think of which number to put here so that you can get 2x back, and the number is just 2. It's easy. Does that make sense so far?
Yes.
If you open this bracket, you're going to end up getting 2x minus 2. But is 2x minus 2 your numerator here?
No.
So how do I get my 2x plus 3 back?
U plus 5.
This is what I meant by the box. I'm not asking anyone to draw a box. And I don't know why somebody drew a box and sent to me, even though I just corrected someone else. The box is just to say, oh, something must be here. What is that thing that must be here to get this back? So it's you asking yourself a question. Oh, after I achieve this, let's see what it leads to. It leads to this. Then you need to think, is this exactly what I used to have here? No. What do I do to this to get this back? Oh, I need to add something. So this box is what do you do? I'm not asking you to draw a box. And I'm not asking you to put K. So that is plus 5. So all I need you to do is just to put plus 5. And after you put your plus 5, you can check yourself. Open the bracket, 2x minus 2 plus 5, and you get what? 2x plus 3, which is exactly what you used to have. So this is your the stuff that you need to do. This is a transformation, if I may use that word. So you have transformed this function into this form. Then you can break it down, and the rest is history. So I don't want to see K bracket because I didn't ask anyone to put some K. Is that understood, please? All right, Lillian, I got it. Brandy, I got your work now. Brandy, you didn't see what I'm doing to my neck? I'm sure you can see me from the video. I have to turn my neck, and I've said it before.
I'm sorry, this one I couldn't take in this, like, my scale will be too small if I turn it horizontal. I mean, yeah,
okay.
Vertically. I'll take the next one vertically.
All right, thank you. Then your work is incomplete. You just stopped at y equals 2 bracket x minus 1 plus 5 over x minus 1. Is this the end? Is that what we did?
Oh, wait, no. We need to put K and...
Right. Karen, I'm looking at your work now. Karen, what is this PM blah, blah, blah doing here?
I thought we had to copy though.
No, you copy that to your notes. Well, this, I don't need this.
Okay.
Understood? I don't need that.
Yes.
Thank you. This is all you need to do.
Okay.
All right, let's see who's next. Nakita, I'm checking your work for number 2. Yeah, makes sense. Krista C, checking now. Krista C, check your work for number 2. If you open the bracket, Krista C, can you hear me? Can Krista hear me, please?
Yes, I just discovered on
All right, so please take note, this part only, okay?
Okay.
All right, so I'll check the other one. I'll let you know if there's anything wrong. Mm. 6, that's 6x minus 7. So what is 5 over 6 times negative 7? That's minus 35. Crystal, the other part that has a number, can you hear me?
Which question?
This one. Can you see this? Can you see this, please?
Yes.
I don't expect 2 minus anything. I expect one number. In our example, there is no way we could find what Q minus something is. Those are letters. So I do not expect you to write letters, to write it like a letter. Q minus something means something. So I want a single number here, not something minus something. Is that clear? All right. Crystal K, checking your work now. All right, let's see if we had 47 by 6 to that. Get our 2. Very good. Crystal K.
Yes.
All right, look at this part. You don't have to write this, please.
Okay.
So leave it at this. So leave it as this. So it is easier to see that you have X function at the bottom, but it's okay. I'm only saying you don't have to bring this down and simplify properly. Is that clear now? So whatever your numerator is, as long as your denominator becomes large, everything becomes 0. So you don't have to waste your time trying to simplify this. Is that clear?
Okay.
And Krista, look at what I said earlier. Krista, see now. You see this? You see what she did here? Krista, see, please.
Yes, I see it.
Yeah, it's just a number. That's what I expect from everyone. All right, thank you.
Okay.
Lillian, question 2 received and checked. Question 3 actually. Is it question 2 or question 3? Question 3, okay. I'll come back to question 4 later. Venom, checking your work now for question. Yeah, that's also correct. Similar to what I just showed you in someone else's work. So that's good. Well done. Clarissa, I'm checking 1. Clarissa, can you hear me?
Yes.
All right, so can you see the screen? Can you see your work on the screen?
Yeah.
All right, so this makes sense. Breaking it down makes sense. So if you want to use implied, it should be implies then y. This implies that y equals this, not y is equal to this, which is equal to this, implies this plus this. What is this? What does this mean? This is your y. So if you want to use implication symbol, your y should be here, the implication at the back. So can you please change that?
Yeah.
So then if it is called y, then you have no business saying f of x.
Oh, okay.
Okay, if it is called y, you have no business. Everybody please listen to that. If the function is called y, you have no business saying f of x, because I never said it is a function f. It could be a g, it could be h. All right, so just leave it as y tends to 1 plus 0. Thank you. Okay, Callista, I'm checking the correction, I guess. Seen, very good. Karen, I'm checking your work now. Very good. I checked question 2 for Karen. Nakita, I check question 3. Very good. Brandy, there's nothing like K, and you didn't complete question 2, and even your question 1. So if you have done all this again, please send to me. This is your question 1, and I complain about K and the box. I haven't seen the adjustment. Now this is your question 2, even though I still have to turn my neck, that's fine. Can you see your question 2?
Yes.
Wait. Complete it. And you can see what I'm showing you about every other person's work. Now this is your question 3. What is this K is equal to this? What is K? I can't remember doing anything and ending with K. Hello?
Yes. Wait.
Do you want me to put the example on the screen? Do you want me to, maybe I send you everybody the picture of the example so you see what exactly I need you to. This is our current class. Yeah, something's recorded, okay. So I'm sending the picture of the class so far. So please follow the instruction, follow exactly what we did. There's nothing like K. If it is called F, use F. Clarissa, this is what I mean by implies. If you are using the implies, please maintain your Y. And when you get to this point, as x tends to infinity, I can't see that in any of Brandy's work. And it keeps writing K. There's nothing like K. And the conclusion is the horizontal asymptote is Y equals something. I can't see anything like K here. And I don't know why some work it stops here. This is not what I asked you to do. Is that understood, mister?
Yes.
Good. All right, I check the next one now. Krista K, checking your work for question 4. All right, question 4 needs to be adjusted. Okay, rearranged. Okay. So negative 4/3 times negative 4, you get 16 there, then minus 7 over 3, and you get your plus 3 back. Very good, very good. Well done, Krista K. And you have that. This is brilliant, Krista. Krista, Miss K. Hello.
Hello.
Now, this should be equals to, please, not implies. If you're going to use imply, then you have to write y is equal to again. So y equals to this, which implies that y equals to this, or y equals to this, which is equal to that. That's the only thing I need to say here. Every other thing is perfect. Well done. Akita, question 4. Oh, you brought out the entire minus. Okay, no, you made a wrong assumption here, Nakita. Can you see my screen?
Yeah.
This minus means everything is minus. But that's not the case here.
Oh, so should I just like put the negative on?
So if you're going to even
the
use
upper part,
if you're going to use the minus here, then this should be minus 3. Because this minus is like a bracket here.
Oh, okay.
All right, so if you're going to use any minus here, so this should be, if you're going to use minus here, this should be minus 3. So which means it will change whatever you had here. But you don't have to go through all this stress. because it's going to end up affecting your calculation by the time you split them into two. Now this minus here should actually affect this one also, because this minus is for everything. So what you should do is say minus 4x plus 3 from the beginning and work with that. Okay?
Okay.
All right.
Okay. So I just rearrange like the position of.
Exactly.
Okay.
Okay. So basically, that's exactly what I saw in Crystal's work now also. So minus 4x plus 3 divided by 3x minus 4. So this is what you should do. So just the way you treated 5, just treat minus 4. That's all. Understood? Okay, Leo, I got your question 1 now. That's correct. Question 2, perfect. Well done, Leo. Wait, is this Leo or Brandy? Yeah, I think it's Leo. No, that's Brandy, not Leo. Okay, that's Brandy. Question 1 and 2 received and correct. Mr. Cheng, okay. You change f of x to y, okay. Since you have noticed that yourself, change it, that's fine. Mr. Cheng, are you there?
Yeah.
Okay, like I said again, we don't need all this. All right, but I've seen what I need, so that's fine. So if this helps you to write it properly, that's fine. But I want to see it. So this could be your own additional information, but this is what I want to see. All right.
Everything else good?
Yeah, everything looks good. Apart from that. Okay. Then your question 3. 7/6. Yes. 3 is good. Question 2 is good. Karen, work received. Question 3, good. Received question 3, Karen, well done. Crystal C, you change your work. Yep. Crystal C.
Yes.
Question 4. Shouldn't that be -7/3? Show you what I mean, because looking at it, I show you what I mean. Can you see this here? Because 3 is actually smaller than 16/3, remember? So this should be a negative number, which means it should have been negative somewhere. Understood? So this should have been negative, okay? So this should be negative, actually. Everything looks okay apart from that. Even though it becomes 0 and your answer still remain this, but this is negative, okay? All right. Okay, so correction received. That's not 25/3. That's not 25/3, Nakita. Because, Nakita, are you listening?
Yeah.
Now, if at this point, look at this point. If you open this bracket, you're going to get -4x and you're going to get what? +16/3, right? So now, are you saying +16/3 +25/3 is going to give you back your +3?
Oh yeah. I changed it.
All right, so take note of that. Okay. Clarissa, checking your work now. 2 looks good. 3 looks good, I think. Yep. 4 looks good. Well done. All right. Callista, checking your 4 now. Well done. Good. Brandy, I just saw your 3. That's 7/6, yes. Good, good job. Karen, I'm looking at question 4 and it's not complete. Why do you send me half work, Miss K? Miss K.
The other part is on the next page. I'm still taking the picture.
Can you see me rolling my eyes for you?
Yes. Okay. Just
Right.
a second. Okay.
Yeah, right. I roll it again. Leo, did you finish your work? Mr. Leo?
I sent number 1, 2, and 3.
Okay. Leo?
Yeah.
Okay, is this your number 1? Confirm.
Wait, let me see. Yeah, this was the number 1.
What is this? Can you tell me what you wrote here?
Oh, it should be Y.
So it will be y equals x over x plus 1 over 1, which is equal to 1. Is that what you're saying?
I should put that down also. Sorry.
Can you look at what I did here and say exactly what I did? I don't know how many times I have to say this, mister. The step where you put brackets, the step where you break it down, the step where you write this in a simpler form, this becomes this becomes this, then you use as x tends to infinity. I can't even see that in your work. F of x tends to this. Then the conclusion. These are the things I want to see. None of them looks like what you sent to me. You wrote horizontal asymptote is this. Where is the tends to? Where is the limit? Even if your calculation is right, what is k? If you need help with this, you need to speak up and stop giving me what I do not expect of you. I'd rather you tell me you don't understand or you need an example than you give me a disappointing solution. Miss V, I just saw your question 4. Very good. Karen, I just saw your question. Uh-oh. Oh, okay. Break it down. Karen.
Yes.
Me, all right. So you have this, then you have the next picture. So my understanding is you expanded the bracket at the bottom, right? To get 9x.
Yes. Yes.
You don't have to do that, but it's okay.
Also, you can just keep the whole thing.
7/3 at the top, and because they're going to vanish anyway. It's going to be 0. So what's the point spending 2 seconds or 3 seconds to expand the bracket? Okay? It's going to vanish. All right. It's like wasting water.
Sorry, my Wi-Fi just died.
Jenny, did you hear that? It's like wasting water on a dead plant. It's dying already.
Okay.
We can drink the water somewhere. Yeah, somebody said something. Was that Brandy or Leo? Oh, Wi-Fi.
Me.
Mr. Wi-Fi.
Yeah, my Wi-Fi.
Okay. Nikita, I received your question 4. Is correct now. So I think, is there anyone who hasn't turned in question 4?
Me, I'm on my way.
All right, Mr. Me, I'm on my way, whatever that means. Okay, so This is how you find your y asymptote for this task. So while we're waiting for him, we're going to try to do some of this correction. So hopefully that can help Leo with all his half solution and, you know, giving me what I do not ask him to give me. So Leo, you especially, you should pay attention if you have issues with this. Y equals x plus 2 divided by x plus 1. X plus 1 will be at the bottom, so I need x plus 1 here. Because this is already x, there's no need for brackets, so I'm just going to write my x plus 1, and I have my x plus 1. Then I think, what can I do to make this and this the same? I need to add 1 to this. Then with that, you can now break it down. X plus 1 divided by x plus 1. Then 1 divided by x plus 1. So which is 1. Then 1 divided by x plus 1. So this is still your y. Right now that I have written it in this form, as x tends to infinity, this part tends to 0. So that's why we say y tends to 1 plus 0, which is 1. And with this, we can say equation of the horizontal asymptote, therefore, the horizontal asymptote is y equals 1. That's all I ask you to do. I didn't write anything K. I didn't write all the other things that you keep showing me, and I don't know where all those came from. Any question? If you have question, please speak now. I'm talking to Leo especially.
No.
I don't want to hear any, I don't want to see any K in any solution, please. So I'll go straight to question 4 because of our time. So for question 4, most people have done that also. I'm still getting a message, Mr. B. Okay, so your message now. Right, 16 minus 3 minus 4, I don't know where that came from. You're still using some of this formula. Anyway, now y equals 3 minus 4x divided by 3x minus 4. Okay, so the first thing I advise you do is rewrite it by rearranging this as that. So now we're going to try to bring this in. Of course, this is not, if this is 3x, this is not 3x. If this was minus 3x, then we just put minus and we have our 3x, all right? But this is, there's a 4 there. So it means there will be a need for a constant. And of course, we have agreed that the constant is always the coefficient of x like that. So definitely it's going to be minus 4 over 3 divided by 3x minus 4, everything at the bottom. So your job is to find out what number is this. Of course, this is going to be 3x minus 4. So I go to my working paper, and I will do my working paper now. And I will open this bracket. So if I open this bracket, negative 4 over 3, 3x minus 4 will give me, this is negative 4 over 3 times 3x, negative 4 over 3 times minus 4. So while this is negative 4x, no, negative, is that 4x? Yes, which is what we need. Negative 4x, this will be plus 16 over 3. Now, this 4x part is okay, but this is meant to be plus 3, not 16 over 3. Then I think again. I have 16 over 3. but I need 3. What do I do to it? So which means what you need to do is 3 minus 16 over 3. Now this is going to be 9 over 3. 9 minus that is negative 7 over 3. So I know this is going to be negative 7 over 3. So I don't want to write plus or minus, so I'm going to erase it. Now go back to my usual color. Then I have minus 7 over 3. That's all you have to do. So now that we have that, of course, this is not needed to be seen. This is your own rough work. And check again. You can always use your calculator. This times this minus this, then plus that. Choose your calculator to check if you get this back. If you do not get it back, then something is wrong. Then, so this is going to be minus 4 over 3 divided by 3x minus 4 divided by 3x minus 4. Remember, this is 3. Looks like something else. So this is minus 7 over 3 divided by 3x minus 4. And there's no need to simplify this. So this is simply that. If there is space here, you can write it. So this is negative 4 over 3. Then this minus is going to be in the middle. I have my 3x minus 4. Then I have my 7 over 3. Now all this is y. Okay, all this is y. If you have your equality, you don't have to write your y in each step. Okay, we understand that. OCD, 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 OCD. All right, see what I want to erase. Yes. So that's my y. Then you say as x tends to infinity, y tends to negative 4 over 3 plus 0 or minus 0 this time, which is negative 4 over 3. Okay, therefore, horizontal asymptote is y equals minus 4 over 3. That's all I ask you to do. Questions?
No.
No.
All right. So now that we have been able to figure out our horizontal asymptote without the inverse function. So again, we have learned inverse function. If the answer is just pick from the equation, if you are just to pick from the equation without showing any workings, just consider the coefficient of x from numerator and denominator, and that's it. Okay? And your vertical asymptote is just when you equate this to 0. So we are not going to discuss that because we've discussed it before and because it doesn't really, it's not so difficult, so we don't want to waste time. So to sketch, there's something else we also need to consider to sketch our graph, okay? It's called the sign diagram. Okay, it's called the sign diagram. The sign diagram actually tells you the behavior of the function near the asymptote. Okay, before the sign diagram, we should also take note of, let me see, the intercepts. Okay, we take note of the intercept. All right, let's see how much of this we can still take before we go. No, sorry. Can you still see my screen?
Yeah.
Okay, so we're going to discuss the sign diagram quickly. We don't have to, or maybe let's do it this way because I actually want us to sketch, but at the same time, I don't know if we need to practice more on this vertical and horizontal asymptote using this method, or I just go straight to the sign diagram what I'm trying to achieve is this. If you want to sketch, all right, if you want to sketch, we need to get the vertical and horizontal asymptote. So you need to know if this is this and this is that. If you have this, we are not sure if the picture will look this way or if the picture is going to look this way. So the sign diagram will inform us what happens when the picture is getting close to the asymptote. Okay, and the sign diagram is usually like this. So you have some plus, minus, sometimes you have 3 signs telling you it's at the negative before this number and something like that. So, and I don't think 10 minutes will be enough to actually do that. So I don't want us to rush things and it becomes confusing. So maybe what I would do is to just give you some functions, some rational functions, and ask you to find both the vertical and horizontal asymptote. Of course, to get the vertical asymptote, just equate denominator to 0. And to get the horizontal asymptote, you have to do it exactly the way we did this. Does everybody get that? Nice?
Yes.
Yes.
And what if I ask you for the y-intercept? Everybody look at this. What is the y-intercept of this function? What is the y-intercept of this function?
1.
1? Are you sure?
Wait.
Talking to the whole class, one person responding. What is the y-intercept of that function?
Y equals to 2.
Y equals to 2. How do you get that?
2 to the power 1.
Let x be.
Not 2 over 1, young man. Yes, you said something, Lillian? How do you get the 2?
Let x equal to 0.
Let x be 0. That's how you get it, not just 2 divided by 1. Okay? Who said that just now?
Crystal C.
Mr. C. Okay, thank you. So, of course, you know your intercept. Your intercept, y-intercept is when x is 0. X-intercept is when y is equal to 0. So the homework I'm going to give you will ask for, so maybe we do one together. So we're going to do, maybe not any of this. This will be the last one, then we can go. I will put some functions for you to practice on your own. Okay. Sorry about that. So, intercept. So once you do intercept, so I just say maybe further example. So I call the function y is equal to, I'll pick one from the book. I have x minus 1 over 2x plus 1. Let's take something that's simple. X minus 1 divided by 2x plus 1. Okay, so first question, I want to find the x asymptote, okay? Sorry, horizontal, that's vertical, right? Vertical asymptote. I don't want to find the, that's why. So what I'm trying to find is written in red and my solution will be written in black. So the first question will be about the vertical asymptote. Of course, you don't have to write that when doing your solution. The question will be clear. So if the question is about the vertical asymptote, you know what to do. You just put the denominator to be 0. And that means 2x is equal to -1. Then you get your x is equal to -half, right? Then you conclude and say, oh, our vertical asymptote is x is equal to that, okay? You don't have to show that you can go from here to here. That's allowed. Does everybody get that?
Yeah.
So vertical asymptote is So the next question is horizontal asymptote, and that's what we have just done. So if you want to do that, we have just done that. Y equals x minus 1 divided by 2x plus 1. So I need my 2x plus 1 in the brackets. But I want to get x, so this has to be 1 over 2. So if I open the bracket, I get 1 over 2 times 2x, then plus another 1 over 2. So that's x plus half. But that's not what I have. I used to have minus 1, so I have to subtract minus 3 over 2. Does that make sense? So I have to subtract 3 over 2. That's minus 3 over 2. Subtract 3 over 2 or add minus 3 over 2. So this will be 1 over 2, 2x plus 1, minus 3 over 2, 2x plus 1, sorry, 2x plus 1 here, which is simply minus plus 1. Say as x becomes large, y becomes 1 over 2 minus 0, which is 1 over 2. Therefore, horizontal asymptote is y equals 1 over 2. Okay. Okay, so having said that, next question is about x and y intercepts. So x-intercept is when y is equal to 0. When y is equal to 0, so you have 0 equals x minus 1, 2x plus 1. So if you cross multiply, x minus 1 is equal to 0, and x is equal to 1. So this curve crosses at x is equal to 1. Then y-intercept. So the question says find y-intercept. Just say when x is equal to 0, then we get, put 0 here, 0 minus 1, 0 plus 1, and that is just minus 1. We're going to need this and what we call the sign diagram to sketch next lesson. Let's put this into the Desmos app online. Let's try to see what we have just figured out. So the equation is y equals x slash. So x minus 1 to x plus 1. Is that the equation? Yeah, x minus 1 to x plus 1. All right. Can everybody see the screen?
Yes.
All right. So what do you notice? This is the intercept. This is the intercept. As we have just found, x-intercept is 1, y-intercept is minus 1. Okay. Then also, the asymptote here is y equals half and x equals minus half. So let's see it from the curve also. Y equals half as this one. And see, if you plot that, let's see, y equals 0.5 and x equals negative 0.5. Okay. So you can see that clearly as x becomes infinity on both sides, it doesn't touch half. And of course, look at y also, it doesn't touch that as well. The problem is, without the sign diagram, you don't know if this part is actually here. Does everybody get my point? Maybe this part is going to be here, and this part is going to be here. We don't know. That's why the sign diagram will tell us when do we get positive, when do we get negative. So, but like we practiced today, and of course, one of the questions I gave is to say, find the sign diagram. If you look at this, you see, can you see this? You want to, hello? Can you see what I'm showing you?
Yes.
So we want to be able to figure out the sign diagram in this one. We will also practice sign diagram for this function. So this knowledge and the example that we have done will help us to be able to do this. So this is the order. So when you have to sketch a function, you first find the asymptote because you need to know where it does not cross. You need to find the intercept to know where it crosses. Okay. Rearrange, we don't have to rearrange. This is vertical asymptote. We can find the horizontal asymptote now by doing what we did. Rearrange the function means make x the subject and finding inverse. We don't have to do that. Sign diagram will help us, and that behavior also will help us. Then we can now sketch. If you do not know most of this, you won't be able to sketch properly. So that's why we need to take our time, and I don't want us to rush that today. Questions, class?
No.
No? All right, so I will send you a screenshot of these functions. You can ignore the instruction and just try to find the vertical and horizontal asymptote on your own, okay? Of course, the instruction will be different, so you just find the vertical and horizontal asymptotes. I'm sending you a screenshot of that now. If there are no questions, we can say bye to the class, and I'll see you on, when is our next lesson now? On Thursday. Yeah?
Yes.
Okay. I've just posted some functions in the group. Don't worry about the instruction on the paper. You just use those functions to practice the vertical, horizontal asymptote, and the intercepts. Practice, no submission required. Okay? I'll see you next time. There's another one. This one has been broken down. The last one I sent is been broken down into two. This is mixed fraction, okay? This is mixed fraction, okay? This, the other one, can everybody still see my screen? Hello?
We can see the board.
Oh, the board? Oh, okay. How about now?
Yep, we can see.
Okay, so this is improper fraction because you can write them as mixed fraction, okay? This is also like improper fraction because you can write it as, now this is mixed fraction. When I say mixed fraction, like having 2, 1/2, okay? So this is now a proper fraction. The proper part of it is what tends to 0 when x tends to infinity. Does it make sense? Class, does this make sense? Does what I said just make sense to you?
Yes.
All right. Is Ethan Chang the only one in the classroom?
Yes.
All right. Okay, so practice this and I'll see you on Thursday. Goodbye, everybody.
Bye.
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 Bye.